Thank you and welcome back to our fourth video, our third video on derivatives. So this video is going to be talking mostly about theory of derivatives. The first topic that we're going to be talking about in this video will be the table of derivatives, which you can see up here. I'm going to be talking a little bit about how you can go about getting some of these derivatives. And some of these, if you were watching the previous video, we've proven, or I have asked you, or I have challenged you to prove yourself. And then we're going to be talking about the rules for differentiation, which can be found over here. And then after we're done with this stuff, I'm going to clear everything up, and I'm going to talk very quickly about what is a second derivative, and also introduce something called prime notation. And then we'll be working through an example or two about evaluating a derivative at a point. So just really quickly, talking about the summary of basic differentiation formulae. The first is the one that we proved in the previous video. A times x to the n. Finding the derivative of that is simply just a times n times x to the n minus 1. The proof for that is using the binomial theorem. That's going to basically be taking care of most of the derivatives that you'll be working with in calculus. The second, the derivative of the sine, is simply just the cosine. Any of these trig functions you can prove using trig identities. The third derivative is the derivative of the cosine, which is negative sine. You can use a trig identity to obtain that one as well. And then the third type of trig derivative is the derivative of tangent of x, which is 1 over cosine squared of x. And once again, you can use a trig identity to obtain that. So we have two more types. d dx of a to the x, which is the natural log of a times a to the x. And if you notice, something that we can, a little trick that we can do, if we set a equals e, e as in the natural number, the natural log of e is 1, and a is e, so d dx of e to the x equals just e to the x. And you can also prove that using the formula for instantaneous rate of change. And then the fifth, another thing that you can use, that you can prove using the instantaneous rate of change is the derivative of the natural log of x with respect to x, which is just 1 over x. And this becomes important, especially when we get into integration, because you'll understand when we get to integration. But if you were to find the integral of 1 over x, you can't integrate 1 over x without running into issues of dividing by 0, so that becomes simply just a rule, natural log of x. So some rules for differentiation. Okay, so these will be used for a few samples later on. So the rules for differentiation, the first rule is that the function must be continuous. So a rule that's generally taught in calculus courses is differentiability implies continuity. So it has to be continuous to be differentiable at a point. So if, for example, the absolute value of x. The absolute value of x, as you should know, has a plot where it kind of looks like that. It kind of has a sharp turn. A sharp turn doesn't mean that it's continuous. So if you see a sharp turn, that means it's not a differentiable function. It's differentiable outside of here. But if you were to try to find the derivative as x approaches 0, well, if you were to find the limit as x approaches 0, from both sides you'd run into issues of the slope. I mean, you'd find the slope being positive x from the right and negative x from the left. -1, +1 and -1. The second rule, the derivative of sums is equal to the sum of the derivatives. So, if you were to take the derivative of f of x plus g of x, f of x plus g of x combined, that's equal to the derivative of f plus the derivative of g, both with respect to x. And the third rule is more of a generality, that products and quotients do not generally. This isn't 100%. There are some exceptions. I'm not going to go into those. But products and quotients do not generally follow this rule. Namely, the d dx of f of x, g of x, does not equal to the derivative of f times the derivative of g. Okay, so keeping these rules in mind, let's go through a couple example problems. So let's use d dx equals 3x squared. Oh no, we want to find d dx of 3x squared. Sorry about that. So d dx of 3x squared. By using rule 1, a x to the n, we can get 3 times the derivative of x squared, which is 3 times 2x, which is 6x. So there's another way they can write a derivative, is f prime of x. So if the function is f of x, the derivative is f prime of x, and the reason why we do this is for bookkeeping purposes, because there's something called a second derivative. So if we wanted to find the second derivative, or d squared dx squared of 3x squared, we want to find two derivatives. So we want to find the derivative of this, which is so d dx of 3x squared, what we found earlier is 6x. We want to find the derivative of this again. So d dx of 6x equals 6. So the second derivative d squared dx squared equals 6. And so another way that we can write this is f double prime of x equals 6. Now if we want to find a third derivative, d cube dx cubed equals f 3 prime of x. The derivative of 6 is simply 0. So that's how you find higher order derivatives. You basically just repeat the process. And then in order to, the final topic of this video is evaluating a derivative at a given point. So say we wanted to find the slope of the line. Say we wanted to find the slope of this line at x equals 2. So the general notation for this is df dx x equals a. The big bar x equals a generally means that you want to find the derivative at a point, the slope at a point. So let's quickly find the derivative of this. So the derivative of this is 6x plus 2. X at x equals 2. So all we have to do is plug in for x. So 6 times 2 plus 2 equals 12 plus 2 equals 14. So the slope of 3x squared plus 2x plus 1 at x equals 2 is 14. So let's do one more quick example involving something that's not. Okay, so let's do a trig function. So d dx of sine of x. Let's not do 2x because we haven't done the chain rule yet. The sine of x. At x equals, let's do something simple, 0. At x equals 0, so the derivative of sine of x equals cosine of x at x equals 0, so plugging in x equals 0 into x, cosine of 0 equals 1. So the slope at x equals 0 of the graph of sine of x is equal to 1. So thank you for watching this video on derivatives. Next time I am going to be showing some more rules so that we can do, for example, the derivative of x sine of x, or the derivative of sine of 2x. So we'll be doing this in the next video. So thank you for watching. If you have any questions, as always, please post in the comment section below. And as always, please subscribe. Thank you for watching, and I will see you in the next video.